Okay, so we're talking about binomial theorem, which is happens to be section 10.3. And you guys, a binomial, just to remind you, looks like this. It could be x plus y. That's a binomial because it has two terms in it, right? It could also be like x minus y. Oopsie, forgot the x part. Here, we'll do that. Okay? So those are both what you would consider a binomial. Okay? Now, one of the things that we often have to do when we have binomials is to multiply them out. So if I have x plus y times x plus y. And on the CAS, you can actually write this expand button.
Isn't that just foiling?
It's foiling it, yeah. And the CAS will actually expand it for you. But being that most of the times on our test you can't even use the CAS anyway, we're just going to talk about it. So x times x is x squared, correct? Yeah. X times y, and then x times y, that makes 2xy's. And then we have a y squared. What are my coefficients here?
1.
1, 2, 1. Look at this. 1, 2, 1. Okay? If we were going to go and do that again, you would actually end up with 1, 3, 3, 1. Kind of like this. Hey, you noticed something already. This next one's going to be 1, 4, 6, 4, 1. What does that look like?
And then it'll be 1, 5, 10, 10, 5, 1.
1, 5, 10, 10, 5, 1.
And then it'll be 1, 6, 15, 20, 15.
Damn.
Okay, so this is a lot like something that we studied yesterday. It's called the Pascal's triangle. Okay, so we just said this looks just like Pascal's triangle, which is what we studied yesterday in 10.2. And let's just move on down here. It says the activity shows that the coefficients of the terms in the expansion of x plus y to the nth are the numbers in the nth row of Pascal's triangle. Consider x plus 3 to the third. Okay, so here we have, if you were to multiply all these out, here's all the different coefficient possibilities you would get for that one, or all the different pieces of it. Okay.
It says in red, but it's all black for us.
Oh, okay. Yeah, circle the red parts.
Color print is way too expensive.
So this is what they're doing, is they're taking x times x times x to get x to the third, right? How many x to the thirds do we have? Just one, right? Okay, this one's x, x, y. So how many of those do we have? Here's 1, here's 2, and here's 3, right? So we have 3x squared y. And then we have xy squareds. How many of those do we have? 1, 2, 3. Yep, plus 3xy squareds. And then we have only 1 like that. Okay? So that looks just like what we had up here. Notice that the coefficients are the same as the coefficients here. So basically, if you look at the pattern, you can use these coefficients in Pascal's triangle, and then just, notice that the degree of the x goes down by 1, and the degree of the y is going up by 1. So it's a lot easier than having to actually go through and calculate, especially if you're going like x plus y to the 6th. That would be not fun, right? Okay. So that is what that looks like. Let's move to the next page. So in general, the binomial theorem is this. Notice that this is the combination principle that we used to find all the terms in Pascal's triangle yesterday. So n choose 0 of the first term, n choose 1 in the second term, n choose 2 the third term, and so on. Okay? So for example, x plus y to the fourth. Okay? So already, if we go and look at our Pascal's triangle. Our fourth row is 1, 4, 6, 4, 1. So I'm going to write that down up here so I can see it. 1, 4, 6, 4, 1. Those are going to be the coefficients of our letters, x and y's, okay? So the first one we have is going to be x to the fourth. What's the coefficient for that one? 1. Do we have a y on that term? No. The next one is going to be 4, x to the third y, right?
Wait, hold on. Where'd you get 3? Where'd you get 4? Where'd you get 6?
Okay, so 1, 4, 6, 4, 1.
Oh, that's one of them.
That's the Pascal's triangle in that row, the fourth row. Okay? Because we're in the fourth power.
Okay.
And I'm always starting with the top power for x. So we're in the fourth power. We're going to work our way down to 0 power. We have 0y here. Then we're going to work our way up to fourth y.
Where are you getting this from?
Okay. All right. So this next term is going to be what? Plus 6x to the second, y to the second. See, we went down 1 degree for the x's and went up 1 degree for the y's. Okay? And then it's going to be 4x to the first, y to the third. Okay? And then the last one is going to be 1. And there's not going to be any x's there because it's going to be x to the 0. So it'll be y to the fourth. Example 1 says, find the power of y and the coefficient of x to the third in term. Okay, so back to what I was trying to say. We're going to try to find this term when we multiply everything out. But I don't want to have to write out my entire sentence here to figure it out. So what we're actually going to be looking at is 8, choose 3. Okay? Remember how to find 8, choose 3.
Why are we cooking 3? Oh.
Don't you do
Because it's,
8 exclamation points
yep,
over
5 exclamation points, 3 exclamation points.
yep. And then the shorter way of looking at this would be, we're going to take 8, 7, 6, because there's 3 terms. 8 times 7 times 6 over 3 times 2 times 1. Okay? If you did that and you calculate it, I lost my page already, you're going to get 126. Okay? So, the coefficient for the x to the third term is 126. So it would look like 126 x to the third, y to the what? If we have to the 8. Yep. Because those two have to add up to be 8, right? Okay.
Seems like a huge jump.
Okay, Seaver had a Seaver moment. Okay, look. Let's just cross it out. You guys, I was looking at the next problem, and then I wrote down the wrong 56. I know, it's called getting old.
Wait, why is it
56.
56?
All right, so we're going to do the same thing for this one. X plus y to the 9th. So it's going to be 9, choose. Now, here's the thing that kind of threw me when I was doing these, okay? You don't know what this one is. You're not going to put 5 there, actually, because it's actually larger than halfway across. So what I want you guys to think about when you're looking at this is, remember that when we find our choose, it's going to be n choose k. So to find it out, it's going to be n minus k is going to equal your power, whatever your power is, okay? Okay, so, or it could be r, that's the same thing. Okay, so if you want me to change it to r, I can.
Why can't it be 5?
Because this number is actually less than halfway. The other one was further than halfway. So I just want to notice that, okay, well, what's half of 9? 4.5. And so we need to think backwards. This one we had only the exponent of 3 across. So that's part of the reason.
But is it the same as?
So, listen, so in this case we have 9 for our total n, right? Okay, so n minus r is going to equal our, we need the fifth power, right? So how do I solve for r?
Was that a
You,
9?
you add, subtract 19 on both sides.
It's-
Wait, what is that? It's a 9 or a 19?
It's a 9,
Just add.
because this is what the 9. So if I add r to both sides and subtract 5, I'm going to get 4 for my r, okay? So now I'm going to use that 4 for right here, okay? So now, we are going to do 9 times 8 times 7 times 6. We need 4 spots because we have 4 here for r. And then 4 times 3 times 2 times 1 on the bottom. And when you do that, you actually do get 126.
Shouldn't it go to 5, 9 times 8 times 6 and 16?
No, you don't count the 5.
Doesn't work the same.
But it goes to 4.
Yep, well, if I did 5, look, 5. Look what happens to 5.
Why is it 5 on the bottom?
Because if you went, that ends up being 126. So that's going to mean that the coefficient for the fifth term, so it's going to be 126, x to the fifth, y to the fourth. So that's what it should look like there. Okay? All right. So there's also something we have to use when we're applying the binomial theorem, and it's called grouping, and you guys have used grouping before. Okay? So we can take something and kind of substitute. Now we have this kind of ugly looking binomial which has some numbers in it besides just x and y. Okay? We already know that this, if I were to rewrite this just in x plus y to the fourth, we just did this a few minutes ago. No, we're going to leave it in plus, and I'll show you in a minute. So if I did this, it would be x to the fourth plus 4x third y1, right? Plus 6x squared y2, and that's what we figured out before earlier on the sheet, okay? Plus 4x y third plus 1 y4. This would be the general way of writing it. But what we need to do is replace our x's and y's with this being our x and this being our y.
So you do 3w to the 4th
Exactly, and we'll put it in parentheses. 3w to the fourth.
plus plus 4 times negative, no,
Not yet. We still got 3w to the third.
times
Negative 2. Mm-hmm.
plus 6 times 3w squared,
It should be to the third. Sorry, guys.
3w squared times negative 2 squared plus 4 times 3w times
Negative 2 to the third. Plus.
1 times negative 2 to the 4th.
Very good. Okay.
Wait, is
All right.
4, 3 plus 4 times 3 to the third times 3?
Yeah. So, look. So let's write this out after you actually calculate this. Make sure that you take that to the fourth power. That 3 has to go to the fourth power. So 3 to the fourth power is 81w. Okay. This 3 will be to the third power times 4 times negative 2. So that's going to be minus,
Would it be 81w to the 4th?
yes, minus 216w to the third plus 216w squared minus 9d6w
Oh, this is a plus minus.
plus 16. So example B, go to the fifth row of Pascal's triangle, and let's look at what our coefficients should be for that one. Okay? Because we're looking to the fifth power right here. So back here, fifth row, we should have 1, 5, 10, 10, 5, 1 for our coefficients. So let's write that down. 1, this would be x to the fifth plus 5 x to the fourth y plus 10 x to the third y squared plus 10 x to the second y to the third plus 5 x to the first y to the fourth plus 1 y to the fifth. Okay, so I got the coefficients from Pascal's triangle.
Do you have to have the ones?
No, you could assume a 1 there. Okay. So now we have our general terms here. Now we're just going to replace them with these two terms here. And just put them in parentheses. So we'll have 3 to the fifth plus 5 times 3 to the fourth negative 4y plus 10 times 3 to the third negative 4y squared plus 10 times 3 squared negative 4y to the third plus 5 times 3 negative 4y to the fourth plus negative 4y to the fifth. So now the coefficients get really big. Okay? So we're going to start off with 243 minus 1620y plus 4,320y squared minus 5,760 y to the third plus 3,840 y to the fourth minus 1,024 y to the fifth. Okay, so a coin is flipped 5 times. How many possible arrangements of heads and tails have at least 2 heads? How many possible arrangements of heads and tails have at least 2 heads?
That'd be 5, choose 2.
Yeah, so there, if you think about it, if you're flipping the coin and you have at least 2, there's, oh, I can't write today. At least 2 could be, you could have, starting off with 2 flips of heads, right? You could have 3, you could have 4, and you could have 5. Those are the different possible happenings when you flip the coin. Okay, so we're going to make a little chart here just to make it a little easier to look at, okay? So we have number of heads, okay, and we're going to have number of tails, and we're going to have sequence type.
Not real.
And then we're going to look at arrangements. First possibility is 2 heads. And if I have 2 heads, how many tails am I going to have? 3. Okay? So we could have it look like this. We threw a coin 5 times. If only 2 heads show up, then the rest have to be tails, right? So then we have heads, heads, tails, tails, tails. So that would be 5, choose 2. And the number of arrangements that can turn out that way is 10. Okay? So we have a total of 5 different possibilities. Okay. Okay, so now this one is going to be 3 heads. So how many tails am I going to have? 2. So that could be heads, 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 tails, tails. So that would be 5, choose 3, which once again ends up being 10. Okay? So the next one's going to be 4 and 1. So you could have heads, 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 and 1 tail. Okay, so that would be 4, choose 1.
5, choose 1.
Oh, sorry, 5, choose 1. Sorry. And that would be 5 possibilities.
How is 5 choose 3 10 possibilities?
Because it could be,
Because we're looking at 5 throws.
it could be head to head. Why is number 2 or 5 choose 3?
Okay, 5, choose 4. Okay? It's 5. But you know what? 5, choose 1 is also 5, just so you know. Okay, then we have 5 and 0. Okay, so that would be all heads. Okay, and that would be 5, choose 5, which happens to be 1. Okay? So, then if you were to total all those numbers up, how many do you have? 26. 26 possible arrangements. Okay? So now, this is going to be related to this right here. It says, find all the terms in h plus t to the fifth, in which the power of h has at least 2. Okay, so what we're going to do is make another, yep, we're still doing the same thing. So we're looking at another chart here. We're going to do power.
Oh, wait, can I go?
Okay, power of the h's. Okay, we'll have power of t's. We're going to have product type. And we're going to have coefficient. Okay, so power of 2. So that means we have h to the second. What's our t going to be? 3. So the power of t will be 3 here. And our coefficient in this case is going to be 10. It's going to be the same. Okay, if we have power of 3, our t is going to be power of 2. So it'll be h to the third, t to the second, and once again our coefficient is going to be 10. Okay, let me extend my lines here. Power 4. For h's, we'll have power of 1 for the t's, so that'll be h to the 4, t to the first. 5, yep. And then this is going to be 5, and then how many t's are we going to have? 0. So h to the fifth. So this will be just one possibility there. Yep, they have the same. 26 possible, right? All right. So basically, our coefficients here are 10 h squared t to the third. And then we also have 10 h third, 10 t to the second. We have 5 h 4 t, and then we have 1 h to the fifth. The total, if we were to actually say what are all of our total possible arrangements, that would be 2 to the fifth, right? Not taking the ones out that we took, not the 26 that we took out. 2 to the fifth equals what? 32. So we would have a total of 32 possible arrangements, right? That's the total of arrangements.
Wait, 26 possible and 32 possible?
I mean total arrangements. Well, it's total possible arrangements. You guys could put that on top. But this is 26 possible t squared or bigger, or h squared or bigger, because we were looking at power of 2, power of 3, power of 4, power of 5, right? So the reason why we're setting this up is, guess what we're going to get into here now?
Heads and tails.
We're already in heads and tails.
So.
Probability. We need to talk about probability. There's your assignment. Okay?